Hello, how are you doing? Welcome to this video. My name is Mr. Okello, Samphonicus. In the previous video, we looked at the reaction of benzene. We introduced that and we said benzene majorly undergoes electrophilic substitution reaction. We said electrophilic substitution reaction is that reaction in which a hydrogen atom on benzene is replaced by an electrophile. And we said an electrophile is an electron deficient species. We gave examples of electrophiles and we gave examples of electrophilic substitution reactions. So in this video, we want to look at the general mechanism by which this electrophilic substitution reaction occurs. So, general mechanism of electrophilic substitution. Now, these electrophilic substitution reactions all follow a similar mechanism which involves majorly 3 steps. The first step is called generation of the electrophile. So, we are saying that in electrophilic substitution, we replace a hydrogen atom by an electrophile. Therefore, we must have a step where we generate that electrophile. So, generation of the electrophile. And how do we generate the electrophile? We simply react a reagent. Say the reagent is E plus a catalyst, say D. And what do we form? An electron pair is transferred from the reagent to the catalyst. So we shall have the reagent has lost electrons, therefore it is positively charged, and the catalyst has gained electrons, therefore it is negatively charged. That is the first step. The second step is called attack on the electrophile by the delocalized electrons on the benzene ring. Attack on the electrophile by delocalized electrons on the benzene ring. So, we have the benzene ring. We have the benzene ring there with the delocalized electrons. Now, the delocalized electrons attack the electrophile. So we have an arrow moving from the delocalized electrons to the electrophile. Therefore, the arrow should start from the delocalized electrons to the electrophile. So what do we form? We shall form an unstable intermediate in which the electrophile is attached on the benzene ring. So how does it look like? We have the ring there with these bonds untouched and the electrophile attached there. And remember from the structure of benzene that there is always a hydrogen atom at every corner bonded to a carbon atom. Now, the delocalized electrons here were rotating around this area, but now they are being used to bond to the electrophile by this carbon atom at the corner there. Therefore, this carbon atom remains electron deficient. Therefore, we have a positive charge at that corner. So that is the unstable intermediate form. So the next step is regeneration of the benzene ring by proton loss or hydrogen ion loss. So regeneration of the benzene ring by proton loss, in brackets hydrogen ion loss. So what happens here? We have the intermediate, which is unstable, with the electrophile attached there and the hydrogen atom there plus a positive charge there. Now, the hydrogen atom there breaks off, and when it breaks off, it donates these bonding electrons in this bond to form back the delocalized electrons. So we have the arrow starting from that bond coming to where there are delocalized electrons before. So what do we form? We form our stable benzene ring, but with the electrophile attached there. So we have the electrophile there, but we have lost the hydrogen ion. Therefore, we write the hydrogen ion there. So those are the three major steps involved in electrophilic substitution reaction. One of them is generation of the electrophile. The second is attack on the electrophile by the delocalized electrons on the benzene ring. Then lastly, regeneration of the benzene ring by proton loss. Now, to practice the two videos, we have unique numbers that you can attempt. One is unit 2012, paper 2, number 4A. Unit 2012, paper 2, number 4A. Then we have unit 2011, paper 2, number 5C. So practice those numbers, and thank you for watching the video. May God bless you.